Formative 1 for week 2 is going to be due this Wednesday, the 29th at 5 p.m. So this formative is 2 parts. In part A, you're going to read and annotate this text on air masses. Again, I'm going to read the text aloud and model which details to highlight and how to accurately answer the check for understanding or the stop and jot summaries. This is the annotation rubric that you're graded on. And for part B, you're going to answer these application questions, which I'll also go through. All right, let's get started. So as we read, we're going to annotate for details that describe different types of air masses, their sources, and their characteristics. Okay. What is an air mass? Air masses can be found all over our Earth within the troposphere. Remember, last week we read about the troposphere being the lowest level in the atmosphere, and it's responsible for all of the weather we experience. We're just going to learn this week how it works. An air mass is a large body of air that has similar temperature, pressure, and level of humidity throughout. That's important. I'm going to highlight it. When an air mass remains stationary, I know stationary means it's unmoving, motionless, still, static, not moving. Okay, so when an air mass removes stationary above a specific location over land or water for long enough, it will take on the properties of that location in terms of its temperature and its moisture or dryness. Okay, so right now you're going to stop and jot these 2 questions. In your own words, describe what an air mass is. And then number 2, what happens when an air mass remains stationary over a specific location for a long period of time? You can go ahead and pause this and then press play when you're ready to move on. When winds move air masses across Earth's surface, the air masses carry their original properties in terms of temperature and moisture or dryness level from their source location to new locations. And I'm going to see what source location means. I'm actually going to highlight that too because it seems important. And source location just refers to an original location that an air mass comes from. So when an air mass reaches a new location or region, it might interact with another air mass that has a different temperature and humidity level. Again, humidity describes the amount of moisture that's present or the amount of dryness of the air. So if something is very humid, that means the air is really moist. Like during the summer, when the air feels really heavy, it's usually very humid and it contains a lot of moisture. But when the air is really dry, that means it has a low humidity. So these interactions between different air masses are what cause drastic or like dramatic, huge, major changes in the weather we experience. For example, it can cause severe thunderstorms to occur at a point where 2 air masses meet. I'm going to go back and highlight these interactions are what cause drastic changes in the weather we experience because that seems important. So right now you're going to stop and jot your answers to what does the term source location mean and how do air masses cause drastic weather changes? Again, pause the video and then write your stop and jot answers and then resume playing when you're ready to move on. How are different air masses classified? I see here, you see a map with a bunch of letters and regions highlighted in red or blue. It seems like those might be air masses and their classifications might be represented by these letters. So let's see what they mean. The area over which an air mass originates is what provides its properties. I'm going to highlight that. The longer the air mass stays over its source region, the more likely that it will acquire the properties of the surface below. Seems important. As such, air masses are associated with high pressure systems. They're 2 broad, overarching divisions of air masses based upon their moisture content, meaning how moist or dry they are. I'll highlight that. Continental air masses designated by the lowercase c, I'm going to highlight the little c, originate over continents, like land, and are therefore dry air masses. Maritime air masses designated by the letter M originate over oceans and are therefore moist air masses. That's pretty easy to remember because I know M, maritime, moist, moisture, wet. So you're gonna pause for a second and answer your stop and jot. What is the difference between continental air masses and maritime air masses? Make sure you describe where each kind of air mass originates, as well as the characteristics in terms of how dry or moist they are. Each of the two divisions, maritime and continental, are then divided based on the temperature content of the surface they originate. Go ahead and highlight that last fragment. Arctic air masses, designated by the letter A, are very cold. So I'm going to highlight A, cold. They originate over the Arctic or Antarctic regions. Okay, that's easy to remember. A, Arctic, Antarctica, cold. Polar air masses, designated by the letter P, are cold. Oops. But are not as cold as the Arctic air masses. Let's go ahead and highlight that because it's a detail describing characteristics of air mass. Polar air masses originate over higher latitudes and above both land and sea. Close to the North and South poles. Tropical air masses, designated by the letter T, are warm or hot, and they originate over the lower latitudes above both sea and land. Lower latitudes are closer to the equator. So you have a few stop and jot questions. One, where do Arctic air masses originate? If you were following along and you annotated, you should have no problem answering that. Describe the temperature of Arctic air masses. Number 3, where do polar air masses originate? Number 4, describe the temperature of polar air masses. Number 5, where do tropical air masses originate? And number 6, describe the temperature of tropical air masses. Go ahead and pause, write your responses, and then play when you're ready to move on. What do air masses look like when they're classified on weather maps, like this one that you see here, which shows North America, like the US, Canada, shows some of Central America, air mass source regions. Okay, let's see. A continental Arctic air mass, shown as CA, let's highlight that, continental Arctic. So continental, I know that originates over land, and Arctic, I remember that means cold. So let's see if I'm right. Which source is over the poles and are therefore very cold and dry. Over land that is near the North and South Pole. Okay. All right, now that is near or above, within the Arctic regions. Okay, continental polar. Not as cold as Arctic air mass, but is also very dry. Why? Because it is dry due to its source region being land. All right, maritime polar air masses are cold, but they're moist due to its origination over oceans. The desert region air masses are represented by CT. Let's go ahead and make that a different paragraph. Meaning continental tropical. Therefore, they're dry due to their source of originality over land, but they're hot because they're tropical, right? They're near the equator. Maritime tropical air masses, MT, are warm in temperature. However, they're more moist due to their origination over oceans. Okay, so now you're going to pause, finish up your highlighting, and stop and jot your answers to these 4 questions. Number 1, describe the characteristic of a CA air mass. 2, describe the characteristic of a CP air mass. 3, describe characteristic of an MP air mass. And 4, describe characteristics of an MT air mass. As these air masses move around the Earth, they begin to acquire additional characteristics. For example, in winter, an Arctic air mass, meaning very cold and dry air, can move over the ocean, picking up some warmth and moisture from the warmer ocean, and then become a maritime polar air mass, one that's still fairly cold, but now contains some kind of moisture because it traveled over the ocean. If that same maritime polar air mass continues to move southward, starting from, say, Canada south through the United States, it'll pick up some of the warmth from the ground in the US because it's moving close to the equator, south, right? But due to a lack of moisture, it did not travel over water. The air mass will still remain very dry, and that's called a continental polar air mass. For the stop and jot, you're going to describe, for number 1, what you think would happen if an Arctic air mass, if a continental Arctic air mass traveled to another location over an ocean. Then number 2, what do you think would happen if a maritime air mass moved over, if a maritime polar air mass moved over dry, warm land? Why? All right, so for part B, what you're gonna do is, sorry about that. Identify which air mass, CP, MP, MT, or MP, would originate from each of these regions in the pictures. And you're going to give the labels underneath each picture. So for 1, you see there's water and there's a sun. I'm going to assume it's warm water. So what would that be? MT, MP, CP, or CT? Air mass 2, I see glaciers. It's kind of cold. There's water. Write the classification. MP, MT, CT, or CP. Here, it's clearly a tropical island. There's a lot of water. If an air mass originated there, what would its classification be? And then here, I see a lot of snow. It's on land, right? So what would this air mass be? Put the letters. Here, I see a lot of water. And there's a lot of like glaciers and snow that's melting, so there's a lot of moisture there. So if an air mass originated there, what would it be? And number 6, it looks like it's pretty dry and there's land. I don't see any water nearby, so what would this air mass be?